All right, hello everyone, and welcome to our webinar. We have about 130 people registered today, so you all are muted and your videos are off, and we're going to cover more of this, but we ask you if you have questions, please put them in the chat. We are recording this webinar, so before we dive into our speakers, I'm going to give a couple of housekeeping details and an idea of the agenda today. First off, my name is Retta Brugger. I'm the Regional Specialist in Rangeland Management for CSU Extension, based out of Grand Junction, which is on the western slope of Colorado. Our webinar today, we're really excited to host several experts who we have here in the state who've done research for a number of years that's very pertinent to rangeland management in our state. So we're lucky to have them today. Before we dive into that, I wanted to remind everyone that CSU is an equal access and opportunity university. And to that end, we provide reasonable accommodation for linguistic access or any other access that is needed for you to be able to understand this presentation. We will be posting a closed caption copy in about a week after this webinar is recorded. So if you need reasonable accommodations, please let me know, or accommodations that are beyond what I've just mentioned, please let me know. This does include language access. You can email me at retta.brugger@colostate.edu or let me know in the chat. Etiquette for today is, again, everyone is muted, your videos are off, and this is just because the number of people who've signed up for this webinar. We do want to hear your questions though, so we're going to ask that you put those into the chat. Time permitting, we'll read out a couple of questions after each speaker. If we don't have time, we'll move on to the next speaker and we'll answer the questions at the end of the webinar. Potentially, speakers also may respond in the chat when they're not giving their presentations. So hopefully we will get to all the questions that are asked. If we are Zoom bombed, which I hope we are not, we will shut down the webinar. We'll record the speaker's presentations and then we'll send it out again as a closed captioned webinar. So will be the protocol if we are Zoom bombed. Ultimately, the webinar will be posted at my website, rangemanagement.extension.colostate.edu. And under the recorded webinars tab, we'll also alert you all through an email when it's posted. Finally, we'll be doing a few polls throughout the webinar, and those are optional. Of course, if you're driving, you don't have to participate, but it does give us a sense of who the audience is. And then at the end, we'll be evaluating the webinar, which gives us a sense of, how impactful this was, if you learned anything, if you're going to apply it to work that you do. So without further ado, I want to introduce, generally, many of our speakers today come from the Rangelands Resources and Systems Research Unit and the Central Plains Experimental Range, which is run by the Agricultural Research Service. This is an extremely old research facility. It was founded in 1935 in response to the Dust Bowl, and research started in 1937. And what's really exciting about this is it gives us unprecedented knowledge and a time frame of knowledge of ecological processes, a livestock weight gain, and all sorts of things that really would be impossible without the length of research that they've been able to conduct at this research facility. So, of course, our researchers are all under 80 years old, but they are part of this research legacy. So we're really excited to have them today. Our agenda, I will also post into the chat, but you can see here, we have quite a few presenters, so it's going to go very quickly. So we're not covering, of course, all 80 years of research, but it will give you a sense of some of the findings and some of the work and the application to management that they've been able to discover over these past years. And then finally, we'll end with Rachel Mead, who's from the USDA NRCS, who will talk more about practical application in terms of the NRCS. So with that, I'm going to stop sharing my screen. And our first presenter is Annie Overland. Annie, while I am introducing you, please go ahead and share your slides. So Annie Overland is my counterpart on the Eastern Plains of Colorado. She serves the Eastern Plains and the San Luis Valley as a rangeland management specialist for CSU Extension. Annie also comes from a 6th-generation ranching family, and she's heavily involved, as well as her family is involved in conservation and livestock issues in that area.
It's so great to see all of you here joining us to learn about stocking rate. So let's get started. Colorado's grazing lands are incredibly varied, starting with our sagebrush ecosystems to the west, transitioning into our mountain meadows, and then transitioning again to the shortgrass prairie on the eastern plains. And so therefore, when it comes to a particular grazing strategy, whether that is continuous grazing, multi-paddock, there's lots of terms for grazing strategy, it comes down to understanding how your system reacts with your grazing system. One of the most important ingredients for figuring out a grazing strategy is figuring out how many animals our ranch can hold over time, otherwise known as our stocking rate. So first, we're going to talk about how to calculate stocking rate. We'll go over a quick example, and then we'll dive into some long-term research from the Central Plains Experimental Range about how stocking rate affects both animal weight gain and vegetation of the shortgrass prairie system. Both are important for longevity of your operation. So stocking rate comes down to two basic parts of the equation. How much forage do my animals need, and how much forage do we have? So we're going to start with the amount of forage that my animals need. This is called forage demand. Forage demand is based on research from both feedlot research and range grazing research. Basically, animals eat approximately 2.5 to 3% of their body weight per day. So for a 1,000-pound cow, this is 26 pounds to 30 pounds of dry matter per day. That value, the amount a 1,000-pound animal eats in a day, is called an animal unit. And if we scale that to a month, it's an animal unit month, or an AUM. We use the AUM to rate how many animal units a pasture can sustain, and that defines stocking rate. Now, we use AUMs a lot with if we were to look at our ecological site descriptions for how many animals a pasture can sustain, or like a real estate advertisement. But really, we use the animal day for grazing management, for rotational grazing, because we can get a lot tighter. And I like to conceptualize an AUM as the amount a cow eats in a month as a big round bale. My family we harvest hay, and a lot of our round bales weigh anywhere between 800 to 1,000 pounds. I conceptualize an animal day as half of a small bale, so half of a 60-pound bale that you might throw to a horse. So if I could harvest 9 half small bales, assuming my cow eats 30 pounds a day, she can stay on that acre for 9 days, or 9 cows could stay on that 1 acre for 1. Now, not every animal weighs the same and therefore eats the same amount. So to make it easy, we use a multiplier to correct for different size animals. Recall, 1,000-pound animal eats 26 to 30 pounds per day, and that comes out to 780 to 930 pounds per month. But if she weighs 1,200 pounds, we need to make up that difference. And so we multiply that value by 1.2, and we'll get 31 pounds a day. So here's my little motley herd here. We're going to calculate the forage demand of this entire herd. So you'll see that we have 3 kind of smaller 1,000-pound cows. That equals 3 animal units. We have 3 calves that are grazing. They're about 400 pounds, and so that equals 1.2 animal units. And then we have 1 600-pound yearling, so a 0.6 animal unit. And that total comes to 4.8 total animal units. So if we multiply 26 pounds a day times 4.8, that gives us to 124 pounds per day. Multiply that by a month, so times 30 in this case, and we come up with 3,744 pounds per month. So forage supply. Now we're on the forage supply side of things. We're going to calculate pounds per acre in AUMs on 640 acres, so on a section. So in this particular pasture, we have 500 pounds that grew in that in that per acre in that pasture. Our pasture is 640 acres, so multiply that and we come up with 320,000 pounds total. Now, we're not going to graze all of that off. Remember, we only want to take half, leave half when it comes to grazing an actual plant, because we want to have plenty of photosynthetic surface for that plant to regrow. And then also, cows are messy eaters. We want to leave a little bit of forage also for, animals, other animals and insects. So we're going to subtract another 30%. So really, we're only going to multiply that total amount of forage by 30%. And we come up with 96,000 total available forage. So if we do a little bit of practice up here on the left side, upper left, we'll see a 400 pounds per acre pasture. Multiply that by 30%, and we come up with 122 or 120 pounds total available forage. On the top right, we have an 1,800 pound per acre pasture. Now, I subtracted the sagebrush because cows aren't going to eat sagebrush for the most part. So basically 30% of that is 540 total. And of course, when I'm thinking about, I'm always thinking, how much could I harvest off of this? So 120 pounds, for example, per acre, that's going to be just 2 small bales. So not a lot. So how do we measure production? I use 3 different methods to measure production, and I use all of them. So the first is I will throw out multiple hoops to get representative hoops of what's out there. And then I'll clip to what the cows would eat. And then I dry that. I air dry that. I don't oven dry, but air dry. So I just put it in my windshield. I also use the wrap tool, which is a remote sensing tool. And that remote sensing tool is based on satellite imagery and infrared. And then the software is trained with data that's already been collected on the ground. It's a predictive tool, but it also gives production on an annual basis. And then, of course, we can read our ecological site descriptions from Web Soil Survey at NRCS. And they give you a range of production based on soil map unit and based on the state or how healthy that range is. Now we will calculate numbers of AUMs you can support on this pasture. So say this pasture right here, we have 160,000 total available pounds of forage. We're going to divide that by animal demand, so 930 pounds in this case, and we come up with 172 AUMs on 640 acres, or 0.26 AUMs per acre. So in my world, that's roughly a third of a large bale. We often hear, in my country, we talk more regularly about acres to the cow. So that's basically just the inverse of the equation that we've been doing. I often hear this is 70 acres to the cow, or this is 60 acres to the cow type of country. And that is referring to the numbers of acres it takes to sustain a cow for a year, but also through a drought season. And that's really how we calculate it here. Other parts of the state, we might be referring to just a 5-month period. But basically, we'll just do an example. It's acres to the cow, so annual forage demand per cow divided by usable forage per year. And this is on a year basis. So in this example, our cows are, I'm using air dry weight, 10,905 pounds per year. And we divide that by 120 pounds of usable forage. And that equals 91 acres for a 1,000-pound cow. Now, the important thing, of course, that I mentioned before is really it's so much about how your range and how your animals are holding up to stocking rate. And so stocking rate should constantly be changing from year to year. A fixed stocking rate is really a myth. And so now we're going to segue into hearing about David Augustine's work that really gets to some of the details on the shortgrass prairies, to some of the data about how both animal weight gain and vegetation responds to different stocking rates. And while we're getting our poll up, I'll introduce David. David Augustine is an ecologist with research interests that include plant herbivory interactions on the ecology of the semi-arid grasslands. His current research examines interactions among cattle, prescribed fire, and prairie dogs on the shortgrass steppe, and the effects that these have on vegetation heterogeneity and grassland birds. And now we are going to start our first poll.
Meanwhile, we have a question in the chat. Is air dry weight the same as DM weight?
Air dry weight is the same as, so there's oven dry weight and there's air dry weight. So David, correct me if I'm wrong, the 26 pounds per day is based on oven dry weight. Is that correct?
Yeah. That's dry matter. So dry matter intake is an oven dry weight. So that air dry weight will usually be a little bit less, or it won't be, it'll be a little bit higher than the oven dried weight. So you may need to apply a small correction to an air dried weight, but they can be very close as long as you have low relative humidity with your air dry, which we often
In
have.
Colorado, we tend to, and that's a very good question, because that was a part of our discussion that we had, because that is confusing. So thanks for the question.
Well, all right, David, we're seeing your slides, and I think you just need to hit start slideshow. And while you do that, I'll share the results for the poll. Looks like we got a mix of answers in terms of flexibility of stocking rate. Let's see, about 45% of people are changing year to year based on conditions. Some, a minority, strong minority, are not changing. Some aren't sure. And then you can see there too as well, about 35%, or well, greater than that, 35% are grazing fewer heads as animal weight gains have increased. Some are grazing fewer days. And I would say a minority are not indicated I don't in response to how do you account for increasing average cow weight. So I think that sets you up pretty well. I'm going to stop sharing the poll and then over to David.
Okay, thanks, Retta. So I'm just going to build upon what Annie was presenting in terms of how we approach estimating the long-term or the average optimal stocking rate for a given pasture or property. And think about a couple different ways of estimating stocking rates. What Annie was just discussing was based on the forage production and how that matches demand. But there's more than one way to estimate stocking rates. So I'll talk about that first, and then again, talk about how forage supply in any given year rarely matches the long-term average and how that affects our thinking about stocking rate. So Annie was really focusing on plant-based method of forage supply. I'll return to that in a little bit, but I also want to think about an animal-based approach for estimating stocking rate. And that brings us to the question of at what stocking rate is beef production optimized? So I think it's important to address this because it may not be that if you're just calculating, say, I want to take 30% of the forage, is that really where I'm going to be optimizing beef production, both in terms of size, the number of animals on the land, and the rate at which those animals are gaining weight. And so I know that a lot of people don't have the opportunity to regularly weigh their animals and estimate weight gains, but that is something that we at the Central Plains Experimental Range do with all the animals that are raised on the property. And we also work with a number of other ranchers in Wyoming and Colorado with, this is an example of a mobile scale or we can measure seasonal or annual weight gain of individual yearlings or cow-calf pairs. And why this won't, I think it's very easy. There we go. And we can measure weight gain at varying stocking rates. So at the Central Plains Experimental Range, we typically run multiple different stocking rates each year, light, moderate, and heavy, so that we can look at weight gains as it varies. And then we can also look across years, we can also look across years with varying forage supply rates. And so what I'm going to do is show you an analysis that we did based on approximately 20 years of weight gain measurements for yearling steers at the Central Plains Experimental Range. And there we've been running 4 different stocking rates, light, moderate, heavy, and very heavy, that vary around the NRCS, the moderate stocking rate being NRCS's recommended stocking rate from their ecological site description. And all of this is on pastures with loamy plain, dominated by the Loamy Plains ecological site. And here we measured weight gains of cattle annually from 2000 to 2018, so 19 years. And we are in the 13-inch mean annual precipitation zone. And so what I'm going to be showing you from these measurements, what we look at is on the x-axis here, we look at how stocking rate varies from low number of animal unit days per acre up to high. Annie earlier was talking about animal unit months. I'm going to show you things in animal unit days, but you just multiply it by 30 to get to animal unit months. And then we can look at the average weight gain per individual. And as we typically go up in stocking rate, when we're at low stocking rates, typically animals are not varying much in terms of their weight gains. And then as we continually increase stocking rate, we often see a steady decline in the per animal weight gain. And then we can also calculate total beef production, which is the product of the individual animal gains times the size of the herd. And as we increase stocking rate, the total beef production per acre will go up because we have more and more animals. But it doesn't go up linearly because they're progressively gaining less and less per animal. So I'm going to show you this. So if we were to plot all of the data that we collected over that period from 2000 to 2019 at the Central Plains Experimental Range, this is what it actually looks like. And these two curves intersect at what is shown here in terms of animal unit days per hectare at 23, approximately animal unit days per hectare. Now, this is the analysis that was published. Of course, when we publish, we have to do it in metric units, but I converted these curves back to animal unit days per acre. And so when we do that, we get these two curves cross each other at their where you would optimize total beef production as well as individual animal performance would be at 9.4 animal unit days per acre. So this is really an estimate that is independent of the vegetation and is more looking at your total or the desire to optimize beef production. So then we can also say, okay, step back and say, how does this compare with calculations from what Annie was presenting earlier? If we look at, say, 25 or 30% removal of estimated forage production, how do we get the same answer? And also, how does this relate to changes in vegetation over time? If you were to run, say, a higher stocking rate than 9.4 animal days per acre, what would happen to the vegetation? If you were to run a lower stocking rate than that, what would happen to the vegetation over the long term? So first of all, in terms of how it would, in terms of how it would affect the vegetation, this is inverse here. So the stocking rate is now heavy on the left and light on the right. And what we find from many years of research at our site is that as we increase the stocking rate towards the left, we get a decline in C3 grasses, Pasum and Hiko or western wheatgrass and needle and thread, and a significant increase in blue grama. And if we were to run for a long term, 25 years of no grazing or 25 years of light grazing, we start to shift back towards increased dominance of western wheat and needle and thread and reduced abundance of blue grama. And what we find, this is generally a continuum, but what I want to emphasize with this slide here is that it's a very long-term process. So you don't shift right away, but with 25 years of heavy stocking, we do see increasing dominance of blue grama, and with long-term light stocking, we get increasing co-dominance of blue grama and western wheatgrass and needle and thread. So I just want to go back to this. So on here, if we're running high stocking rates on the right, we're shifting it to blue grama. On the left, we're shifting it towards those cool season western wheat and needle and thread. And here in the middle is where we find that optimal stocking rate. And what we find is this optimal stocking rate from beef production, if we were to optimize beef production, this also corresponds to where we have a dominance of blue grama, but still a minor component of the C3 grasses. Now, we also want to address the fact that year to year, of course, weather and forage production is changing. In this particular analysis, if we drop the drought years out of the analysis and ask if we remove the drought years and run the same at where these two curves meet, it shifts to the right. And our optimal stocking rate actually increases by 10% if we were to remove the drought years. And if we were to run the same analysis only using drought years, the optimal stocking rate would decline substantially. It declines by about 40% in drought years. So then I also want to compare how that optimal stocking rate, 9.4, from weight gains compares to an optimal stocking rate from the forage production calculations that Annie went through earlier. And so I pulled data where we measured forage production on the Loamy Plains ecological site for a decade, annually for a decade from 2013 to 2023. And the average forage production was average 820 pounds per acre. I want to look at what does that mean for a calculated stocking rates. If we go to the NRCS ecological site description for Loamy Plains, they say that the average forage production in pounds per acre is 700. And what we found through measurements over the past decade is we get 820. So I just want to show how the estimated stocking rate varies based on the different assumptions here. So for stocking rate based on forage production, we use the NRCS ecological site description at 700 pounds per acre. What we end up is with 0.19 AUMs per acre or 5.8 animal unit days per acre. Again, if you want to convert that to acres per AUM or acres per AUD, you just take the inverse, so 1 over 5.8. So if we, this is assuming 25% is eaten, 25% is lost, and we're trying to leave 50% of the forage behind on average. But if we assume the forage production is 820 pounds per acre, which is what we've been measuring in recent years, assume 25% eaten, then our stocking rate estimate goes up to 7.6. And if we say, okay, we're gonna actually, we think it's fine to take 30%, which is the number that Annie was using earlier, 20% lost and 50% left, then our optimal stocking rate becomes 9.1 AUDs per acre. So I just want to illustrate here how much it varies based on these different assumptions about forage production. And then here, what we found, this second line down under stocking rate based on animal performance, we found the optimal was 9.4. So interestingly, based on animal performance, we optimize our weight gains and beef production at nearly the identical stocking rate that we would calculate, assuming 30% eaten and 820 pounds per acre of forage production on average. I also just wanted to illustrate that, uh, first of all, this first line is based on animal performance from 1940s and 50s. Those data suggest that we could only sustain a lower stocking rate during the 1940s and 1950s of 5.5 animal unit days per acre. So our overall stocking rate based on modern conditions is significantly higher, and that reflects improvements in our forage condition and forage production over the past 80 years. And then if we were to know in advance that we're definitely not going to have a drought, our estimate of optimal stocking rate for optimizing beef production would go up to 10.4 animal unit days per acre. But unfortunately, we don't have perfect predictions. And if we were to know it was a drought, it would drop to 5.7 animal unit days per acre. So that's just illustrating how much it varies. Now, we can also look at how much it varies from year to year based on forage production. I've been telling you over and over that I'm using 820 pounds per acre as the average over the past decade. But of course, no single year is average, right? So over the past decade, if we calculate it on an annual basis, we've had 3 years where that were extremely wet, that are shown here in green, where we could have run significantly higher stocking rates than the optimal. And then we've got 3 years in that were unusually extreme droughts, in which the stocking rate calculated based on forage supply is considerably lower than any of the estimates that I showed you previously. And so this just illustrates how much uncertainty we have to deal with and how much variability from year to year. So what do we actually do? We work with a number of ranchers in Weld County that are members of the Crow Valley Grazing Association. They provide all of the cattle to the Central Plains Experimental Range that we run there during the summer. And when we work with them and talk with them about stocking rate decisions, what we find they do and recommend to us is that they often adjust down after a drought. Recall what we estimated the optimal is 9.4, but they usually adjust down after droughts somewhere in the vicinity of around 6 animal unit days per hectare is what they chose after the 2022 drought, which was particularly severe. And they adjust up after multiple good years, for example, up above 9 animal unit days per hectare in 2018 due to a series of good years. But most ranchers do stay more conservative than what we calculate as the optimal. In most years, for example, typically running in the range of 7 to 8 animal unit days per hectare, or below what we call optimal, just because of uncertainty in rainfall. So this is like how they're approaching stocking rates prior to the growing season, thinking about whether or not they've had a drought in the past. And then, of course, if you run into a drought, what do you do? How do you adjust accordingly? Based on a survey of ranchers in eastern Wyoming and eastern Colorado, these percentages in parentheses are the percent of ranchers that said they use these different strategies when they go into an extreme drought. First one is to wean calves early. The second one is to sell retained yearling livestock, and the third is to reduce cow herd size. And of course, whether you can sell retained livestock or yearling livestock depends on whether you have a mixed operation. And then the items in green are things to increase the forage supply off ranch, which is either to purchase feed, rent additional pastures, or move livestock to another location. That's just illustrating all the different strategies after you run into a drought. Okay, so I'm going to stop there and move it on to Justin Durner, who's going to talk about cow size. And Justin is so Justin, if you can bring yours up. And Justin is the research leader for the Rangeland Resources and System Research Unit that I work for. And he's been serving in that role since 2010 after joining the unit in 2002. So Justin has been around since we started that whole stocking rate analysis. And Justin was born and raised on a cattle ranch in the eastern part of Nebraska Sandhills.
Thanks, David. Really appreciate that. What I want to do is move to the animal side largely here. And I've got some slides. I want to showcase some trends and some changes that impact our stocking rate decisions. So what I want to show on this first slide is the changes we've observed in cow size over time. This is some data from the USDA Economic Research Service. This is averaged over the cow breeds and the cow operations in the United States. And it shows a remarkable linear trend from 1980 up through 2020. So over the last 40 years, our average cow size has increased 30%. And that has some ramifications in terms of the stocking rate, which we'll address next. Interesting for the U.S. beef production system, we've been able to increase our beef production output in the U.S. because of this increase in cow size, even though the number of cows has decreased. We've done that because we've selected genetics for increased growth in our operations. This next slide showcases the impact then of what's happened over those last 40 years as our cows have increased relative to what we would consider maybe a standard cow herd 40 years ago. And a lot of our stocking rate decisions perhaps maybe haven't been updated. If we used a base cow herd just of 100 cows here, and those cows averaged 1,000 pounds.
Justin, we're still seeing, sorry, I'm sorry to interrupt. We're still seeing the first slide here. We're seeing you're not in presentation mode.
Okay, well, let me change that. We'll go down the second slide. It's showing up on mine, but
Perfect.
it's not. We'll go that way.
That's fine.
Okay. So I'll start back over. Thank you, Lauren. Second slide here. The implications then of our cow size increase on our stocking rates can be showcased here in this bar graph. And what I'll use for a baseline is if we had a cow herd size of 100 cows and they each averaged 1,000 pounds, what would be the change we would need to make in our operation to accommodate those larger cow sizes we now have out on most of our operations? So, for example, if our cows average 1,200 pounds, we would need to run 84 cows now, so a reduction in 16 cows to have the same stocking rates we did with 100 smaller cows. For operations that might have some larger cows, let's say up into the 1,400 pound cow size, which is now the average cow size across the U.S., we would be running 73 cows and a reduction of 27 compared to 100 of those 1,000-pound cows. And so you can see sometimes why we have these interesting situations where grandpa or dad might have run so many cows in this pasture, and now we're still trying to run the same number where we have less grass. We're not having the same stock rate influence. So on average, if you go to those larger cow sizes, we have basically about 30% fewer cows we can run on the operation to maintain the same stocking rates we would with those smaller cows. And then I'll jump down here and wrap up in terms of what we can do on the animal side related to flexibility in our stocking rates. And one is reduce cow size. We've seen that a lot recently with producers trying to move back from a large growth period, selection for growth genetics, to more maternal genetics, and try to match the animal genetics, if you will, to the local environment. And by doing so, then we can increase our cows' numbers and get back into much more of an equilibrium in terms of our cow size to the production environment, especially with the variability in forage production we have. Number two, as David said, we can look at changing our operations, perhaps from an entire cow-calf only operation to a mixed operation where we have cow-calves plus yearlings. So we have some flexibility for animals that could be liquid and moved in dry situations. Some nice information, the data from John Ritten and Alan Terrell, some really esteemed economists in the rangeland side, indicate that perhaps about 2/3 of our operation or our carrying capacity ought to be allocated to the cow-calf side. And that would then reduce the need for us to sell our good genetics during times of drought or dry conditions and allow the flexibility in those yearlings or other operations, right, to bring in somebody else's dry cows or other grazing animals during periods when we have abundant forage. Third we can do is we can alter our on-off dates rather than be prescriptive and always going out to graze on a certain date and coming off on a certain date. We have changes in vegetation composition. We have some cheatgrass invading in some areas where we can go out earlier and utilize that as a very palatable forage. We have some other introduced grasses like crested wheatgrass or others, again, that we can accommodate with an earlier grazing season. We may come off the grazing season earlier to take advantage of marking opportunities, or if the grazing season happens to be in the one with abundant forage, perhaps stay longer and utilize that forage. Number 4 is, I think every rancher, and Rachel will talk to us about from the NRCS side, of having a written drought management plan with some key dates and key triggers to make decisions on your operations. That would then help producers be proactive rather than reactive in herd management decisions, and allow producers to capitalize on economics that might be beneficial earlier in the season when the market will be higher versus when market conditions will deteriorate with more animals coming to the market because of drought. And then number 5, we'll wrap up with, we do have some good information related to long-term climate information that can help us with at least decision trees related to our stocking rate decisions within and across grazing seasons. For example, there's some acronyms there, PDO and ENSO. PDO is the Pacific Decadal Oscillation. So this is decadal type changes in the sea surface temperature off of the Pacific Northwest coast. So when that temperature there in the sea surface is cool, which it is currently, it's tough to get water evaporated up into the atmospheric river and get precipitation over in our environment. Likewise, ENSO is ENSO, El Nino Southern Oscillation. That is the sea surface temperatures at the equator. We commonly know those as La Nina. That's when it's cool. La Nina, and then El Nino when it's warm. Currently, we're in the La Nina, the cool phase. And so again, much like that bathtub situation, it's hard to get that water from the cool temperatures on the equator into the atmospheric rivers to get precipitation to us. So right now we're facing kind of a double-edged sword of cool water off the Pacific Northwest, cool water off the equator, resulting in decreased predictions of having us abundant rainfall throughout the eastern part of the Colorado shortgrass prairie in this growing season. So just in summary, we've had an increase in cow size, roughly about 30%. Our cows are now averaging 1,400 pounds. We've got some large ones out there. That has implications in terms of stocking rate in relative terms, in terms of what we traditionally would have been putting out on a piece of land. And there are some flexibility concerns that we could incorporate into our operations to provide us some adaptation strategies for the individual ranch. With that, I'm going to go ahead and stop sharing. I'll introduce the next speaker. She is Dr. Lauren Perinsky. She's in our research unit, the Rangeland Resources and Systems Research Unit. She has an interest in plant community ecology, plant herbivore interactions, landscape ecology, as well as restoration.
Anyway, so Lauren, take it away. Thank you, Justin, for your presentation.
Okay, I'm so excited you all are here. We're going to shift right now. We've talked a lot about animals, and we're going to shift into thinking more about plants. And the question that I'm trying to address with the next little piece here is how stocking rate and grazing pattern affect rates of use for palatable plant species. So I'm going to tell you a story about a regrazed grass plant. And for this talk, I want you to shift your thinking from animals into like imagining that you are a little grass plant on the shortgrass steppe. And this talk was produced in collaboration with a bunch of the other folks you've heard today, as well as some other people within our ARS unit and a group of stakeholders, including ranchers, conservation groups, and agency professionals. So I'm going to start with what we know about grazing and grass production. So basically, we know that frequent and severe defoliation, so grazing plants, is bad overall for grass production. And that is especially true for plant species that we think of as decreasers. So these palatable species, such as Western wheatgrass, in the North American Great Plains. So David showed basically if we have a long period of heavy grazing, we tend to reduce production for these species in particular. So our Western wheat, our needle and thread, and increase relative abundance of plants that are more tolerant of grazing, such as blue grandma. But the critical question for folks who want to use these lands is how much and how often plants have to, like, how can we limit how much and how often plants get grazed while still allowing animals to utilize forage from these species. So we want to let animals graze these species. They're palatable species, but we want to limit how much and how often they get grazed. One method for doing that is to adjust stocking rates. So we know based on a whole ton of literature and experience on the ground that as stocking rate increases, grazing and regrazing are also going to increase. And I want to point out, as we've discussed already, we can change stocking rate in multiple ways. So we can reduce the number of animals we have, we can reduce the amount of time that they're on a given piece of land. So both of those, changing number of animals and changing time, will change your stocking rate, since rate is animals per unit area per unit time. We've also had some interest in thinking about rotational grazing as a possible method for reducing the amount of time that, or the amount of times that a given grass plant gets grazed, or how much it gets grazed. And I want to point out that existing studies on this have really mixed results. And that's both because of study design. So a lot of these studies have sort of confounded stocking rate with the rotation. And then also, we just don't have very many studies that really test this. For the few studies that have compared grazing systems using the same stocking rates, we have mixed results. Sometimes rotation reduces the amount of defoliation that a given plant experiences. Sometimes it increases it, and sometimes it doesn't change. And most of these studies basically concluded that the effects of changing your stocking rate were way bigger than the effects of changing rotation or no rotation. All right, so these past studies have some limitations. So they were generally done in pretty small paddocks, not at the ranch scale. And they generally had these fixed grazing schedules that ignored the human dimensions of adaptive decision making. So we know in the real world, managers are working at ranch scales. They're adapting management to things like spatial and temporal variation in plant phenology. So when plants are green, they're adapting to weather, they're adapting to different plant community types, and they have multiple different objectives that they're trying to manage. So in order to sort of look at this in a bigger scale and more realistic way, a group of us started this collaborative adaptive rangeland management, or CARM, experiment. This experiment involves 11 stakeholders that work together to try and manage a group of animals. So we have about 480 steers. We're managing across a larger scale, not a huge scale, but 6,400 acres. And then we did this for 10 years to try and, because we know in the system things change slowly, and we tried to sort of look at a longer time scale. These are some of our stakeholder participants and some of our funding sources. This was a really big collaborative project, and I'm really thankful to be a part of it. But I want to point out we had participants from all different kinds of management agencies, as well as rancher participants. This is a picture of where the study was located. So it's just west of the Pawnee National Grassland in northern Colorado, in the shortgrass steppe. And in this study, we really tried to take a collaborative approach. So we explicitly involved multiple stakeholders in the project, tried to draw on different types of knowledge, and we integrated experimentation into the design of the experiment and into the implementation of our resource management. So our overall goal in this project was to manage the land in order to pass it on to future generations, both economically and ecologically. And we had a set of other sub-objectives that fit under that goal. So we had vegetation objectives, profitable ranching objectives, wildlife objectives, and collaborative learning objectives. One of our vegetation objectives had to do with cool season grasses. So we wanted to attain or maintain abundances of cool season perennial graminoids within 30% of targets for each plot. And so with this and all of our objectives, we were trying to figure out how can we achieve this objective with our grazing management. And so what the stakeholders ended up deciding to do was to compare a traditional management regime to a adaptive management plan that involved multi-paddock rotational grazing. So for the CARM or the adaptive treatment, we had one herd of steers rotated through 10 pastures at a moderate stocking rate. We included 2 pastures planned for rest each year for grass banking and to create tall structure for our wildlife species. And we used adaptive movements that considered precipitation, forage biomass, species composition, and seasonality. And we compared that rotational system to our traditional rangeland management or TRM system. And in TRM, we had the same stocking rate. So we had the same total number of animals, but instead of rotating them through 10 pastures, we split those animals up into 10 small herds, put them in the pastures, and graze them there from May to October. So it wasn't year-round continuous grazing, but it was season-long continuous grazing from May to October with smaller herds inside each of 10 pastures. Okay, so then for 5 years, actually we've done this for over 10 years now, but I'm gonna tell you about the first 5 years. We monitored all these pastures for multiple objectives. We put a bunch of plots down and we looked at vegetation outcomes, animal outcomes, and wildlife outcomes, focusing especially on grassland birds. One of the things we found with the first 4 years of our data was that we did not have much difference in production or density of our cool season perennial graminoids. So this is like western wheatgrass or needle and thread in the first 5 years of the experiment based on our TRM versus CARM, so our traditional versus adaptive grazing management. And these plots, you don't need to read them, but basically this is just showing that the production of our cool season or C3 perennial graminoids was basically the same in the 2 different treatments. Maybe a little bit of difference on one ecological site in 1 year, but overall no difference. And this was surprising because we expected that our rotational grazing would help, would increase our cool season grass production. And so we sort of took a step back and asked ourselves, why did we think that our adaptive rotational grazing management was going to help with our cool season grass production? And we did a little questionnaire where we asked ourselves, all the stakeholders and scientists filled out this questionnaire about like, what is our hypothesis here? Why did we think that our grazing management would help our cool season grasses? And we came up with this hypothesis. I'm just going to read it. So we expected that collaborative adaptive multi-paddock rotational grazing, by reducing the amount of time cattle graze in a paddock, would decrease the occurrence of repeated defoliation of individual palatable plants within a grazing season. So we thought that that decreased defoliation of individual plants would in turn increase production of those palatable cool season species. And so once we figured out that hypothesis, we thought, oh my gosh, we could actually like just test this hypothesis. Like, does this rotational grazing system decrease repeated defoliation of individual palatable plants? And so it wasn't easy, but we decided to get down on our hands and knees and ask whether the rotational grazing led to less regrazing on individual plants. And so we did this sub-experiment where we found 30 tillers of western wheatgrass, which is a palatable cool season grass in our system. And we tagged them and monitored them along 3 transects in each pasture. So in the rotational pastures and in the continuous season-long pastures. And we also monitored tillers in pastures that were grazed lightly or heavily every year since 1939. So these are light or heavy stocking rates. And then in the moderate stocking rate, we had either continuous season-long or rotational. This is what it looked like. Actually, we had these little twisty ties around these individual western wheatgrass tillers. And then we had very intrepid people with good backs, young people, go out there and look for grazing on these individual plants. And then if the plants were grazed, we took a little bit of white paint and painted the tip of the plant. Very, very small. I don't know if you can even see it here, but then we could come back and see if that paint was still there or if the paint was gone. And if the paint was gone, that meant that tiller got regrazed again. And so we did this for every single one of the 90 tillers inside each one of the 20 pastures. Okay, so what did we find out? The first thing we found is indeed grazing is bad for Western wheatgrass. So we found that this is the number of times that a given tiller was grazed, and we did this whole study twice. So in 2017 and 2018. So I've got 0 times grazed, 1 time grazed, 2 times grazed, or greater than 2 times grazed. This is for each individual tiller. And then we've got change in length on the y-axis. So basically, if the tiller didn't get grazed, it either didn't change in length or maybe it grew in length over the course of the season. And then if it did get grazed, it decreased in length. And the more times it got grazed, the more it decreased. It didn't recover from grazing. So this was like on the individual plant scale, this was bad. More grazing was bad. Okay, so this next figure is showing our different treatments, and it's showing the 2 years here. So we've got columns for 2017 or 2018. And then on the x-axis, we've got our light. Remember, we have our lightly grazed pasture. We have our 2 moderately grazed pastures. So we've got our CARM, our adaptive rotational, or our traditional rangeland management. And then we've got our heavy grazing pasture. So we're showing here both rotation and stocking rate on this figure. On the top here, we've got the proportion of tillers that got grazed at all. So this is like, did the tiller get grazed even once or more than once? And what you can see is about 20% of tillers in the lightly grazed pasture were grazed. About 40% of tillers that we monitored in the moderately grazed pastures were grazed, regardless of if it was rotationally or continuous season long. And about over 60% of the tillers in our heavy grazed pasture got grazed. And this was consistent across years. Maybe a little bit less grazing in 2018 overall. On the bottom here, I'm showing the average number of times a given tiller was grazed. So if you were just a random tiller, how many times approximately would you be grazed in these different treatments? So a lot of these are less than 1%, because remember, not all tillers got grazed even once. So less than 1 times grazed for the moderate and the lightly grazed stocking rates, regardless of whether it was rotational or not rotational. And then if you happen to be an unlucky tiller in a heavily grazed pasture, you got grazed on average more than 1 time. So that heavy stocking rate led to more grazing and regrazing. But interestingly, at the ranch scale, average across all our pastures, we saw basically no difference in regrazing rates between our adaptive rotational and our continuous season-long moderately grazed systems. Okay, this is another way of looking at that same data. So here we're showing our 2 different years again, 2017 and 2018. And then we're showing here the proportion of tillers that got grazed no time, so that's dark blue, ungrazed. Light blue is they got grazed once over the course of the whole season. Orange is grazed twice, and red is grazed more than twice. Now remember, we know grazing and regrazing is not good for this plant. But what's interesting here is that a bunch of tillers didn't get grazed at all, especially in our lightly grazed or our moderately grazed, CARM or moderately grazed traditional season-long, so TRM pastures. And then in our heavily grazed pasture, we have like way more grazing and regrazing. So again, this points to the importance of stocking rate in driving this. Stocking rates seem to be much more important than whether we rotated or not here. However, we did see, so remember, we're not just thinking about a whole ranch, we actually have these 20 different pastures. If we split apart all our pastures and look at rates of grazing and regrazing in the rotational system and the traditional system at a pasture scale, what we see is more variability in our rotationally grazed system among our pastures. So some pastures had low rates of grazing and regrazing, other pastures had high rates of grazing and regrazing. Whereas in the traditional season-long pastures, we saw more consistent responses across all our 10 pastures. So we looked at what was driving that pasture scale difference in rates of grazing and regrazing. So here we're showing, again, the on top, we've got the proportion of tillers that were grazed. And then the colors here are different years. So 2017 or 2018. And on the bottom row, we've got the average number of times that a given tiller was grazed. And basically what I take away from this is within our rotational pastures, we can see that if a given pasture got used for more days, so animal unit days on the left here, if that went up, then we had more grazing and more regrazing. And similarly, if the pasture got used earlier in the season, this cool season species is more palatable earlier in the season. And pastures that happened to get grazed earlier in the season had more grazing and more regrazing on this palatable species. So if you were grazed earlier, or if your pasture was grazed longer, we had heavier use. So again, this is sort of thinking about pasture scale stocking rate, for example, here, our animal unit days per hectare within a given pasture, and timing of grazing. But what's interesting is that at the ranch scale, it didn't matter. So how do we sort of make sense of all that? I think it's because it's a zero-sum game. In this ranch, if the cows weren't in a given pasture early season, they were in a different pasture during those same days during the season. So one pasture could be experiencing light grazing and rest for this western wheatgrass, but at the same time, the cattle were in a different pasture where the western wheatgrass was being grazed heavily at that same time in the year. So across all the pastures, it basically cancels out and you get no difference overall between the rotational system and the season-long system. So I'm just going to summarize 3 lessons learned here. First, stocking rate. Stocking rate seemed to be much more important in terms of whether a given tiller was grazed or regrazed than whether you were rotating or not rotating. And interestingly, we can think about the fact that season-long rest is sort of built into our continuous grazing systems because at the moderate stocking rate, basically 2/3 of the tillers never saw grazing. So if you are a random tiller sitting in a moderately grazed pasture, there's a 2/3 chance that you're just never going to experience grazing in the shortgrass steppe system, regardless of whether the grazing was rotational or season-long. And this is a quote from this paper I found from 1969, which basically says the same thing. So under the system of, quote, correctly, which he means moderately stocked continuous grazing described here, plants were grazed neither frequently nor severely. Individual small areas in these continuously grazed swards were thus grazed rotationally. So basically, like from the perspective of a tiny little grass plant, even a pasture with continuous season-long grazing is, you're not just being grazed over and over again in that pasture because the cattle are taking plants from all around. And I want to point out, there's a lot of limitations to this. This is in shortgrass steppe. This was 2 years of data. So it may be different under other contexts or in other parts of the world. But in our part of the world, this is what we're seeing. Okay, second thing. Grazing system didn't seem to matter at the ranch scale. So our collaborative adaptive multi-paddock rotational grazing did not reduce or increase rates of grazing and regrazing on these palatable western wheatgrass tillers at the ranch scale compared to our continuous season-long grazing at the same stocking rate. So keep in mind, these are both the same total number of animals over the 10 pastures for the same amount of days throughout the season. However, as I said, we did see these effects at the pasture scale. So pastures differed a lot depending on when they got grazed and how heavily they got grazed. I also want to point out rotation may be useful for other reasons, such as management, control, and flexibility, creating wildlife habitat, creating some drought resilience, some grass banking. But just in terms of does it help us reduce grazing rates on western wheatgrass? We didn't see an effect there. And finally, I want to say that grappling with complexities like this, trying to figure out what's going on in our system and developing these additional sub-experiments to try and figure things out, really helped with our learning and progress in our collaborative adaptive rangeland management project and helped to build trust for co-produced science. So doing things in this way, we found to be really valuable. And I'm looking forward to the discussion later on. I'll stop sharing. And I want to introduce our next speaker, who is Rachel Mead. So Rachel, you can share your screen Rachel is a rangeland management specialist for the USDA NRCS at the West National Technology Support Center. Formerly, she was the state rangeland management specialist at USDA NRCS, and she's been with NRCS for 22 years. And we see your screen. It is not yet in slideshow. There you go. Perfect. I'm not hearing you.
Okay, let's see if I can.
We got you now, Rachel. We can hear you.
Okay, I can't seem to find my video, but can you see the slide without the notes?
Yes, we are seeing the correct screen. Yep.
I'm not going to turn my video on. I apologize. I can't seem to find it. Unless
That's
I
okay. You go
head
for it.
back all the way out. So, all right. Really nice to join you guys. I'm going to kind of take a step back, I think, and try to wrap up some of these concepts, but also talk about it in context of NRCS and sort of how we work with the ranchers on the ground at the local level. One of the sort of foundational services that NRCS does is work with ranchers on the conservation planning and developing a conservation plan, or like I like to call it, as a roadmap for your operation. We use a 3-phase, 9-step planning process, and this process happens with you in partnership with us and whatever other partners you want to bring to the table to have those sort of conversations and that learning opportunity. I always think it's really important to reiterate always that landowners and managers are the experts of their ranches. And we really take that into account. You guys know things that we'll never know because you've spent the years on the ground on your operation. Also, it's important to understand that this is your plan and that it's only successful when they're the ones that are making the adaptive decisions regarding their resources. And so we don't make those decisions for you. We just get to bounce around the truck with you and learn from you, and you get to learn from us. So we learn how your operation is working. We learn about your resources. We learn about your livestock. We learn about how you do things. And from us, you get to learn about ecological processes and expectations for your resources, things like the ecological sites and things like how the soils are working, plants, animals, wildlife, all those sort of things. We do it bouncing around the truck talking with you guys, but we also do an offer service where we give you guys a full field inventory to have part of your as part of your operation. I think it's really important, especially after hearing from, there's my video, hearing from Lauren. I like to take a step back and talk about this learning process. And I really would like to look at the slide on the right-hand model. And actually that came from the CARM, some of our adaptive learning that we went through. And I think what's important to sort of realize is that this is often a very circular, very reiterative process. And it is really based on what we're learning and the questions we're asking. And then what do we know and what do we not know? Right. And then how do we monitor and evaluate and experiment to find the answers, just like Lauren said. And so this is done in a collaborative fashion, and we exchange information with each other, and every person is valued for their knowledge that they bring to the table. And then it's fostered through that adaptive process of monitoring and curiosity and experimentation. And you can see from that model that it's not only circular, but it's also circular within circular. And so a lot of times we come back to questions and we'll be like, but what about now? Or what about during a drought year? Or what about on a loamy soil in a wet year? And those are the kinds of conversations that need to take place to sort of make those decisions on the ground that then become sort of adaptive responses. NRCS, you'll see a lot of models of our conservation planning process, and it can be depicted in a linear model, and I don't like that model very much. And so I really like to show our planning process in this circular fashion as well. And I think that you can see that there's on the left-hand side of the slide, we have the 3 phases that we go through, and then these sort of circular ways to collect information and share information within those phases. And we do this in a continual process as well. And we will be coming back to phases sometimes, or we'll be working within a phase and circling in between, like determining objectives or evaluating resources. And as you can sort of see then that there's sort of some correlation between these two sort of models. And they look, even though they're different, there is some similarities as well. So a lot of times people sort of say, well, where's the flexibility in working with NRCS? And I like to sort of say it's at every step of the process, right? And so once we've established your baseline understanding of your operation with you, then we really get to sort of determine where your goals and objectives are, and we can start to work through different decisions that will affect you and your operation, as well as how they might affect your resources. And then we move into sort of then what conservation practices do you need to help you facilitate meeting your goals and objectives. It's really important to sort of recognize that monitoring and evaluation of that monitoring data is really important, because that's where we sort of learn, were our assumptions correct, or did we not account for something? And so I think it's important to recognize that without that monitoring and without that conservation plan, where are we? Where do we think we want to go? And how well did we successfully do that? We find that all of us, and I count myself in that, we make a lot of our own assumptions about what we think we know without necessarily looking on the ground on your ranch. And so that is one of the main services that I really feel like we can provide for you, is on the ground information. I'd like to take one step back and talk about ecological sites, because it was thrown out there throughout all three of the for the presenters, and I want to make sure that we just really understand what they are. These is a planning unit that we all need to be, or that we use in NRCS really, but it's being used in a lot of different places as well, to evaluate potential plant productivity of sort of each acre of land, and then evaluate current condition and plant community responses, disturbances, ecological processes, and then management decisions can be made from that. The picture on this slide, you can see that there's three very distinct plant communities out there. And so it's really easy to sort of draw a line there. What I'd like you guys to realize, though, is that by the time you're talking about the ecological site level, you're all the way down to the soil level. And so there's these models of assumption built into ecological site descriptions that start all the way at the top at sort of the geology level, right? How is this acre of land responding because it's sitting on the Colorado Plateau, or it's sitting in the Great Plains, or it's in the Intermountain West? Then you get all the way down to the soils level, and now you're talking about ecological sites. And now we're talking about how plants are responding to each other. What plants do we expect to see there? What ratio of the plants that they would be growing there? How are they responding to things like drought, fire management, grazing, and all of those sort of things. So I think I just want to take one step back and make sure that when you understand, when you say, oh, well, the NRCS ecological site description says that, that is almost in itself inherently an assumption, right? Because it is now a collaborative or a bunch of data put together to make averages on base how we think that that plant community is going to respond based on the soils. And so again, it's a level of assumption, a level of averages, or a level of modal concepts. And so it's still not happening directly at your ranch level. It is a very good place to start. So when we want to move from assumptions, right, to on the ground, that's where it's really important that you work with a group like your extension, your NRCS, right, to start to have field assessment. And that's where we're going to provide you and landowners with that baseline information to start thinking about your management goals, right? We're going to provide you what soils you have. We're going to provide you sort of precipitation information and trends. We're going to actually look at what's growing on the ground, how much is growing, how are they growing in relationship to each other? Do you have noxious and invasive plants? We're going to look at soil, right? Do you have soil erosion? Do you have other resource concerns out there? We will evaluate total annual plant production by plant species for you. From that, we can start to gather things like forage production, right, for stocking rate. And we'll look at things like cover, rangeland health, and utilization management things, distribution of cattle. How are your cattle using the landscape? That comes from information we gather from you. We'll look at resource concerns. We'll also take a look at your ranch infrastructure, and we will think about things like wildlife and other use considerations. Okay, so NRCS uses a conservation practice called grazing management. We talk in terms of a standard, right, which is sort of that standard applies to how we are going to apply that practice across the entire nation. And then we have state standards as well. And so there's a Colorado state standard of how that standard would be applied in Colorado. But sort of in general, it's really at the minimum, the plan is going to include things like your goals and objectives. We're going to include a map that includes identification of existing infrastructure, supporting and planned. That includes things like livestock water, fence, gates. We're going to give you an inventory of your current forage as well as your planned forage available by the management unit. And then we're also going to talk about your demand, right? And that comes from your livestock demand, but that also could be wildlife demand. And that would be based on sort of what your herd dynamics are, what your herd makeup is. We're going to give you an initial stocking rate based on assumptions, which we have talked about through this entire slideshow. And that will also, though, be consider things like livestock distribution, wildlife use, quality, seasonable availability of your production, and whether you need to use hay production in your operation or not, and other factors that are specific to your operation. We're going to give you, we're going to work with you. We're not going to give you anything. We're going to work with you to document a grazing strategy that identifies how the livestock will graze the management units. And that will describe intensity and timing, duration, and frequency of grazing. And then we will talk with you about contingency plans to serve as a guide, right? Critical dates, critical triggers, for things that will guide adaptive management decisions to minimize or mitigate resource or economic impacts from episodic events. So mostly we think about drought, right? Because we're in the West, and that's our biggest contingency. But there's also other things that could happen too. And so sometimes we need to think about flooding or fire, or sometimes we might have insects that come across and just decimate pastures. And so those are all things that we like to sort of predetermine, but we know that that's not necessarily possible too. So those are things that then become just conversations as we work together as a team. And then we'll set up some monitoring with you, hopefully to help you know sort of what are key monitoring things that you need to be looking at to address those sort of day-to-day decisions, as well as then assessing at the end of the year, how did the plan go? Where do you want to change the plan for the next year? So again, right, we've been talking about flexibility is sort of key, right? Whether it's a stocking rate flexibility or whether it's the planning. And so I think it's really important that you understand that like, this is just a plan, right? NRCS recognizes that like there's going to be a huge sort of range of variability of things that could happen out there during the year. So NRCS will provide you a sort of range of a stocking rate that that initial stocking rate usually comes from things like historic numbers that you've carried on your operation. Maybe current resource conditions. Are you in a degraded resource condition with soils and you want to try to get more cover out there? And so that becomes a goal, right? So your goals and objectives, are you maintaining or improving resources? Your animal herd goals, for example, what, are you looking to improve calf crop rates or ratios? Do you have weaning weights you want to work on? What economic goals do you have for your operation? And then, of course, because we recognize that it's rangeland in the West, right? What other uses are out there that we need to think about as well? And a lot of you are affected by certain species, birds or wildlife, riparian areas, conservation areas. And so we recognize that all of those things are unique to your operation. It's also really important to recognize that this plan is going to change, right? Nothing is locked in stone. And so what we will do is we will help you communicate with us and sort of this relationship now, right? Of sort of what's happening on the ground, what decisions are having to be made, and what could be some best alternatives. We like to talk about things like utilizing checkpoints, which is a date that you need to maybe make a decision, right? Either for drought or for moving cattle or for changing herd size or your stocking rate. As we also will talk about early trigger indications. And so what are you actually going to be looking at, whether that's utilization or whether that's other factors out there. It's important to think about those triggers as sort of short-term monitoring, right? And that's things that can also be things like precipitation, utilization, maybe cover estimates if needed, if you're looking at structure, especially for wildlife. And then that you maintain livestock records, because a lot of times we think we do something and then we kind of forget. And we're like, oh, well, I do it that way every year, all the time. In reality, that you actually did 4 other different things out there. And so we ask that you try to maintain livestock records of what animals did you have where and when, and how many days were they out there. And then we love observations. We love photographs, because that helps us be able to communicate what you're seeing on the ground as the expert of your ranch, but also then what we can see on the ground, being your sort of a technical consultant. I also think it's really, and that's.
Oh, sorry, Rachel. How about we have about 2 more minutes?
Okay, let me go on. I'd like to just talk real quickly about optimization versus maximization. A lot of times, especially with competing goals, you can't always optimize, or you can't always maximize all goals. And so you do need to think about sometimes we need to optimize certain goals and during certain times of years. All right, let's see if I can. So we've talked a lot about how we adjust stocking rates. This is an example of NRCS is using different assumptions. The takeaway, then we also have tools out there that use remote sensing. We have one called Stock Smart out there, and then we have, I put the CSU carrying capacity, but both uses remote sensing to make those assumptions for you. But I think what's really important is that the more we learn from you and your operation, what do you actually have out there in terms of production? What are your actually herd sizes? What is your actual demand? How are you doing flexibility? Then we can start to tailor it to your on the ground operation. And that is sort of something that's different than all of the other assumptions out there with all the other programs, as we're now tailoring it to what's on the ground for you. I'd like to talk briefly about grazing strategies, because I think it's really important, right? I don't care whether you call them strategies, systems, they get talked about a lot. And so I think it's important to go back to 4 sort of universal principles out there. Chronic intensive grazing is not necessarily detrimental to plant growth or survival. Primary productivity can be increased by lenient grazing and decreased by severe grazing. Forage quality is often improved by frequent grazing. And species composition of plant communities can be modified in response to frequency, intensity, and seasonality of grazing. So a lot of these questions about graze or don't graze, rotate or don't rotate, like come back to thinking about some of these sort of universal principles and how they apply on your ranch. Takeaway sort of things where the stocking rate is critical, the more flexibility, the better. Continuous grazing is not necessarily synonymous with being improperly stocked. Rest and recovery can happen at the plant scale. That was a really great presentation by Lauren. And that continuous grazing at the proper stocking rate is not always synonymous with overgrazing. So if we're monitoring and we may be seeing overgrazing or changing in plant community, probably the first question we need to ask ourselves is, what has our stocking rate been? And for how long has our stocking rate been at that level? And what do we need to change with our assumptions? I think it's really important to realize that NRCS really wants to take a look at your grazing management based on ecological process-based goals and objectives, and then monitor with that. We need to make sure that we're adaptive and flexible and given a wide range of climate variability, landowner objectives, resource monitoring, resource concerns, and then of course, essentially that monitoring is a very important part of that. And I think, given the time, Retta, I really only have 2 more slides, but I think I'll go ahead and just wrap it up there so that we have time for some questions.
All right. Thank you so much, Rachel. And yeah, we have about 3 minutes left on our webinar. Lauren or Justin, would you want to jump in and summarize kind of what's been happening in the chat while I work on sharing getting the last poll up here?
Sure. We've been having great conversations in the chat, and there's some links in there for folks to some of the research papers that go over the study that I presented. And typically folks were asking about details about how we ran the study, how many days the given pastures were grazed and recovery times and stuff like that. So all of that is available in the chat. And one thing that came up was sort of regrowth rates. And I did want to mention, we did not see that much regrowth of Western wheat in our pastures. And I think that has to do with our arid ecosystem. I think regrowth and growth in general is really dependent on water. And we've been talking a lot with colleagues in more mesic systems where regrowth is more of a given, whereas in our system, it really isn't. And I think that can really affect the results that I presented. If you do have sort of reliable regrowth of your grazed tillers, then you might have really different outcomes. So I just wanted to point that out, like in pasture systems, for example.
Awesome. Thank you so much. And responses are coming in on the evaluation. So I'll wait for a couple more. If there's any other questions in the last minute or so, please put those in the chat. So otherwise, I'm going to just leave this poll open, but really appreciate responses. For the presenters, we want to thank you all for taking the time to present and the time it takes to prepare and share your knowledge. It is looking like we have 94% of people are responding yes, that today's webinar provided new knowledge. We've got 53 saying that it might influence their grazing strategy and another 50% saying maybe. So I think, what you do has an impact. Thank you for taking the time to, again, share it with us. And with that, I'm going to end the webinar. Again, we will need to close caption this. We'll post it to the website. When that's all done, I'll send out an email to everyone who registered, and it will also be posted on my website. We have one last question. It says, oh, well, it's a comment. I think many misquote mistakes with rotational grazing involve returning before plants fully recovered, in which there would be no advantage to the rotation. One final question, how much of the older research remains relevant to today's grassland research?
David?
I think I could, I think many of the concepts remain valid, but I would just point out that we have seen shifts in our rangeland over the past 80 years, and in general, with increases in CO2 concentrations, we have seen an increase in productivity of our rangeland. In general, across eastern Colorado, eastern Wyoming, at least those portions, we've seen increases in the productivity of our rangelands since the Dust Bowl, and increased capacity to support higher stocking rates. But the principles that you see in some that Lauren quoted in her presentation are still all quite relevant.
Awesome. All right. Well, on that note, we're over time, but again, thanks everyone for coming, and appreciate our presenters, and we'll see you next time.